here's another interesting consequence of the way refraction works. Now, I have to point out here, this diagram is a little bit misleading. It's deliberately exaggerated. But what it's saying is that we actually see the sun for a bit longer every day. We see the sun a little bit before it actually rises geometrically and a little bit after it sets geometrically. Now, the difference is about one diameter of the sun, or about 2 minutes of extra sunlight at the start of the day and 2 minutes extra at the end of the day. It's a very small shift, but it is noticeable. What happens is that air in the atmosphere thickens as we go down towards the Earth. And that means the light coming from the sun, now it's drawn in separate layers, but of course it's a fairly continuous process. As the light from the sun goes into the thicker parts of the atmosphere, it bends towards the normal. Which means when we're standing on Earth and we look up to where we think the sun is, at sunrise or sunset, it's actually just a little bit behind. Now, remember, it's really here, it's very close. But it looks higher up than it really is. And it only happens at the edges of the day, because in the middle of the day, the sun would be coming down, the light would be coming down, I should say, not the sun. The light would be coming down perpendicular to the surface. It comes down at the normal, and any light rays travelling along the normal don't get bent. But at the start and end of the day, they're travelling quite shallowly compared to the normal. Sorry, I said that badly. Quite shallowly compared to the surface, which is actually quite a long way from the normal, so they get bent a bit more. Air is still pretty thin. Even on Earth, we would normally say the refractive index of air that we breathe right now is basically 1.00. So it's not very thick, but it's thick enough to make a difference in where we see the sun versus its real position. Interesting, huh?